Hi everyone, myself Sri Harshvardhan. I am studying BTech first year in Srinivasa Ramanujan Institute of Technology from the Department of Computer Science and Engineering. Today I will discuss the topic of extrinsic semiconductors of P-type and N-type semiconductors. Contents: Introduction to extrinsic semiconductors. Understanding semiconductors. What is doping? P-type semiconductors. N-type semiconductors. Comparison of P-type and N-type semiconductors. Applications of extrinsic semiconductors. Introduction to extrinsic semiconductors. Extrinsic semiconductors are materials that have been intentionally doped to modify their electrical properties. Doping introduces impurities into the semiconductor crystal lattice which can either donate or accept electrons. The two main types of extrinsic semiconductors are P-type and N-type, each with distinct characteristics. Understanding semiconductors. Semiconductors have electrical conductivity between that of conductors and insulators. Pure semiconductors or intrinsic semiconductors have a balanced number of electrons and holes. The conductivity of semiconductors is highly sensitive to temperature and doping levels. What is doping? Doping is the process of adding specific impurities to a semiconductor to enhance its electrical properties. The type of concentration of dopants determine whether the semiconductor becomes P-type or N-type. Common dopants include boron for P-type and phosphorus for N-type semiconductors. In the above diagram, P-type semiconductors are positive and N-type semiconductors are negative. PN junction is the space charge region or depletion layer. P-type semiconductors. In the above diagram, P-type semiconductors majority of holes and minority of electrons. In N-type semiconductor, majority of electrons, minority of holes. P-type semiconductors are created by doping with elements that have fewer valence electrons such as boron. The addition of these elements creates holes or vacant positions for electrons which act as positive charge carriers. P-type semiconductors are characterized by a majority of holes and a minority of electrons. N-type semiconductors. N-type semiconductors are created by doping with elements that have more valence electrons such as phosphorus. These dopants provide extra electrons which become the majority charge carriers in the material. N-type semiconductors have a surplus of electrons and a minority of holes, allowing for efficient conduction. In the above diagram, in N-type semiconductor, donor impurity contributes free electrons. In P-type semiconductor, acceptor impurity creates a holes. Comparison of P-type and N-type semiconductors. In P-type and N-type semiconductors have opposite charge carriers influencing their electrical behavior. P-type has holes as majority carriers, while N-type has electrons as majority carriers. Both types are essential for creating junctions such as in diodes and transistors, which are crucial for electronic devices. Applications of extrinsic semiconductor. Extrinsic semiconductors form the backbone of modern electronics, enabling the functionality of various devices. These are used in solar cells, amplifiers, and digital circuits, making technology more efficient and compact. In the above diagram, valency holes are shown, conduction electrons are shown, conduction electrons are shown, valence electrons are shown. A P-type semiconductor is the example of silicon. In N-type semiconductor is the example of phosphorus. Understanding the properties of P-type and N-type semiconductors is essential for advancements in semiconductor technology. Thank you.